In this video, I want to show you how to get better AI responses by making multiple models collaborate for a single response. See, the way we're using AI models today is kind of like asking one person their opinion in a room full of experts. But here's the thing, there's a clever way of actually getting around that. Sometimes you just want to spam a whole bunch of models to see who gives you the best answer. So the way to do this is by using this pattern called this LLM Consortium. I discovered this on GitHub. And the idea is that instead of just using one model for one question, you set up a consortium of models and you give the same question or prompt to all of them. Now, each model's response gets collected and sent to an arbiter LLM. Think of it as a chief judge. And this arbiter doesn't just pick a winner. It takes the strongest elements of each response and combines them into something more, something better than any single model would respond with. So I'll show you what I mean with this architecture diagram. This is the GitHub repo where I found this. And basically, the start signifies the starting event. And this is where we actually send the query, whatever the question is, to all the models and collect all the responses with this box here. And now we synthesize the responses. So this is the part where the arbiter LLM would, make something for the final answer. Now here's where it gets interesting. It actually also comes up with a confidence score of its synthesized answer and then checks it against the given confidence. So this is something that you actually set up beforehand. And the confidence is like a number from 0 to 1. So if it's not even confident in its own answer, what it'll do is it'll ask the other LLMs to actually recreate their answers with some added instruction. And so it loops back again. We'll get all the responses and then check the confidence. And so you can set up max iterations and things like that, so it doesn't just keep going in a loop. But the beauty part here is that it actually gives you at least some level of quality, and you're leaving it to the judge to figure that out. So I'll show you how this works in an event-driven system that has basically three main components: an events manager, a string templating engine, and an API provider for the LLM API calls. And the example app we'll use gives a financial statement and asks for a financial analysis report back. All right, I'll just dig into how this event system works. At the heart of it all, we have this basically financial consortium class that houses this workflow. And we're using a llama index workflow object for the main engine for the event system. It's just like a perfect fit for this use case. And I'll show you how it works. So we basically set up our members and our arbiter. So these are just the models that we want to use. The prompts I'll get to in a second. But the main thing here is that we instantiate this workflow. And the way the workflow works is that we add a bunch of steps, and each step has an input and an output. So the input is the event that it's going to respond to. So whatever event kicks off, it's going to respond to that event that's defined. And the output is what event it emits once it's done. So in this case, the first very beginning event, this is how we kick off the workflow, is this start event. And what we'll do is we extract the data from the query. So this is basically like the prompt that the question we're asking. And we actually store that initial query, initial prompt in our context of this event system so that we can refer to it later. And from there, all that it's doing is that it's creating the chat messages, basically the format for the LLM API calls of messages that we're sending with this prompt, and then tells each member of our consortium to answer this query. So that part happens here, the context.send event, and then we are emitting basically this new response needed event. So that automatically tells us that there's another step of the workflow that's waiting for this event to be emitted. So if I just scroll down and I look for that, that's this step here. So basically, whenever this gets emitted, we answer it in this step. And what happens here is that we're actually just calling for the completion. So this is the LLM API provided wrapper that I've created, which just for each member is going to send the API request with the prompt. Once the answers come back for each member, we just emit a new event that is defined here as the output event. And so the pattern continues. The step that handles the answered event is the step that's actually collecting all the answers. So if you just remember from a second ago, the architecture diagram where we're collecting the responses and then sending them to the arbiter. That happens here. So basically what happens is we're storing every response into the context data so that we can access it later. And the reason we do that is that these events, these responses are going to come back at various times. They're not all coming back. These are async responses. So we have to store them until we got all of them. And that's what this check here. So unless all responses have returned, we just emit a none event, which really basically says we don't want any other step responding to this. Now, once the responses are back, we emit arbiter needed event, which is going to kick off this step here. And as you can probably tell, in this step is where we put together our arbiter prompt with all the responses and ask it to give us a synthesized answer. So here's the arbiter response. And so in this part here, we have this check that asks the arbiter like, hey, is the answer good enough? And if the arbiter LLM came back with a low confidence score, it will have this needs iteration property on our parse response as true. And in that case, we just emit a new event with our, refinement areas. And these are all sort of properties and fields that our arbiter LLM will return. And so the iteration needed event is just going to kick off that entire process all over again. Now, if it answer is good enough, we actually can just return the stop event. And that's how we actually return the final results to our caller. Now, I want to show you the little neat tricks that we did with our prompt library, which is basically just a string templating engine. You'll notice in the first step, we actually created these chat messages using this member prompt.chat messages method. And we'll just click into that now. And what you'll see here is that we have this sort of constructor and we pass in a templated string. Now, what this constructor does is it gives us a sort of a structured way to put together these chat messages, and in a way so that we don't have to do manual if else or string concatenation or string literals later on. It kind of encapsulates everything within this one class. So if you'll notice, we have this template markers here for chat role system, and that comes all the way down to the end chat. So you can tell that this is all going to be as part of the system prompt for our member LLM API calls. And below that, we have the other part. So the other part of the message is going to be sort of the role user message for the same LLM API call. Now, the beauty of using a templating engine like Nunchucks is that we can have these sort of filter functions. And I'll show you how that works in a bit. But basically, we will pass some object called iteration number into our template so that if the iteration number is greater than 1, this string will be included in our message. Otherwise, it won't be. And now the rest of the sort of double bracketed items are just objects that we eventually pass into the constructed object of new prompt. And so you'll notice we pass it an object of iteration, which is the current iteration we're on, and then the original prompt. And we'll go back to it again, and you'll see you have the iteration number, right? And we have the original prompt here. So it's always going to be included so that the LLM knows what the original message is and sort of keeps good context. And similarly, our arbiter has similar instructions, right? You have this sort of general instruction of its role and what it's supposed to do and how it's supposed to kind of analyze all the data it gets, right? And then the instructions around, does it need iteration? Are there refinement areas if it does need iteration? And then all the model responses will be listed here. So this is sort of where this setup shines. We don't have to manually concatenate all the responses. We can just pass them in throughout our workflow. And so what happens is, down here, let's look and find the arbiter needed event, right? What we do here is the arbiter prompt chat messages constructor basically passes those responses, and we can just pass it as a object from entries of all the responses we saved. And that saves us a lot of code because it's all encapsulated within the string template, as you can see again. Model response. And now the rest of the code is just sort of a couple of helpers I built for parsing the responses and being able to sort of manipulate them within the code, and then some logging. Now let's test it out. Let's see this thing in action. I'm just going to drop a JSON format of a financial statement and we'll hit generate and let's take a look at what's going on. All right, so we have sent requests to Anthropic, OpenAI, and Google. And let's see for their response. All right, so we got the arbiter needed being kicked off. So it makes sense that the arbiter needed event is going to be a little bit longer. Oh, it looks like we have a report. All right, so here's the final response on our front end. We have a confidence score. We have a whole bunch of fields here that we asked for. So it looked like it worked. So yeah, that's it. It was a short demo, but hopefully you get the idea of how you can use this very powerful pattern and maybe adjust it to your needs. Let me know what you think. Open to all comments and questions.